guys, the Unit 1 study practice test, I'm going to go ahead and go over the answers now. As you can see at the top of this test, I want you to realize it'll be the same on the real one we hand out. It has all of the conversion charts that you're going to need for the whole test. So instead of looking them up like we've been doing, they should be there for you to use. So the first question, Newton's second law in 1867, Sir Isaac Newton published his famous Principia Mathematica. It contained his second law of motion. This law is often written as F equals m times a. You can see this is a direct variation. And then look right here, we're talking about they defined the variables. F is the amount of force applied to an object, m is mass, and a is acceleration. Acceleration is given in the units meters per second squared, and force is given in units of newtons. It doesn't say what mass is given in, so we'll just leave it as mass. If a 175 Newton force causes a heavily loaded shopping cart to accelerate down the aisle with an acceleration of 2.5 meters per second squared, calculate the mass of the shopping cart. So let's take a look. Oops. Let's take a look. We have F equals m times a, okay? And we're going to go ahead and do some substituting. F, the force is 175 newtons, and the acceleration is 2.5 meters per second squared. So we just substitute those numbers in and solve for mass. So instead of F, it's 175 equals your mass is what we're looking for times 2.5. Okay. The inverse variation of times is divide. So we're going to divide by 2.5 on this side. What you do to one side, you have to do to the other. So 175 divided by 2.5 gives us, this cancels. Well, it doesn't cancel. It becomes 1, and 1 times m is just m. 175 divided by 2.5 is 7 equals the mass. So the mass of an object traveling 2.5 meters per second squared with a force of 175 newtons is 7. And remember, they didn't have the units for mass there, or which ones that they were using, so is 7. The second part of that is said it wants the force needed to accelerate the same cart at 6 meters per second squared. So this time the same cart, we know that the mass is 7, we already know that, but it changed its acceleration rate to 6 meters per second squared. And it wants to find force. We just use the same equation. So we have our force is equal to our mass times acceleration. And this is a lot easier. We don't have to do any manipulation. We just have 7 times 6. So our force in this case is 42 newtons. In a complete sentence, it would be if an object has a mass of 7 and an acceleration of 6 meters per second squared, then the force would be 42 newtons. Okay. Question number 2. A student found, so this was all over the internet. It's pretty gross, but you can look it up if you want to and see this this worm coming out of this dead praying mantis is the grossest thing you've ever seen. But let's go ahead and read question 2. Dead praying mantis had an alien worm crawling out of its body. If the worm was double the length of the mantis and the mantis was 1/6 of a yard long, how long was the worm in centimeters? So if the mantis is 1/6 of a yard long, the mantis is 1/6 of a yard. Okay, can you just figure out how many feet that would be? That'd probably be the easiest thing to do. We know from the top or from your own head that that 1 yard is 3 feet, and the mantis is 1/6 of a yard. We'll just set up a proportion. Okay, we want to know how many feet that is. So X there. We have 1/6 times, oh wait, let's see, how do you want to do this? We're going to multiply both sides by X and both sides by 3, our denominators. Here the 3's cancel and here the X's cancel. So I have X times 1 is just X equals, and then we have 1/6 times 3. I can change 3 into a fraction by putting a 1 on the denominator. And then we multiply this out. It's 3/6, which is just the same as 1/2. So X equals 1/2 of a foot. Okay, and then let's just in our head change that to inches, since we have a conversion from inches to centimeters. So, and I think the question was asking how long is the worm in centimeters. So we know, oh, and then the other thing we know is that the worm is double the size of the mantis. So X is the mantis, is 1/2 of a foot, then the worm is 1 foot, or we know that that's exactly 12 inches, right? So now we can just set up an equation that is 1 inch. I know 1 inch is from the conversion at the top of the test, 2.54 centimeters. And when you set up a proportion, the units need to be on the same side. So I know that my worm is 12 inches. And I want to know how many centimeters. So we multiply both sides by an X and a 2.54. Right? And then this X 2.54. The 2.54's cancel. We have X times 1 is just X equals. Over here, my X's cancel, and I have 12 times 2.54, which is 30.48. So 12 times 2.54 is what's left. So X equals 30.48. So the alien worm is 30.48 centimeters long. Gross. Gross, gross, gross. All right, you guys, question 3. Proxima b is a new Earth-like planet recently found by NASA. It is a mere 4.2 light years away from our solar system. There are, let's see, hundreds, thousands, millions, billions, trillions. Approximately 9.5 trillion kilometers in 1 light year to the nearest kilometer. How far is Proxima b from the Earth? So let's just use a simple proportion to solve this, since we just have one conversion we're trying to do. Okay, whoops, where are we? Okay, so